Hello and welcome to this video. In this video, we are going to be navigating to the analysis tab, and then we'll carry out the analysis of this steel warehouse successfully, and then we will look at the analysis result just like this. We will proceed to check the deflection of the member just like this, and you also learn how to check the animation of the steel structure just as you can see. We will also proceed to look at the shear forces in the major axis of the portal frame successfully, and we'll also see the reactions generated at the foundation of this steel stanchion successfully through this provision just like this as you can see. And we proceed to the design tab, and then we will ensure that we carry out the design of this model, and all of the members will pass design like this. So you are going to be learning good knowledge in this presentation. Stay connected as we get into these presentations, and don't forget to like and subscribe. Let us get started. All right, this is where we actually stopped in the last presentation. So we were able to carry out the load cases, loading combination, and as well as the loaded envelope right here in the last presentation. Here is the load cases. Okay, we created body wheel load on this structure, and this is the loading combinations right here, so you can see. All right, so this is the load envelope. So we want to be using this to carry out the analysis and design of the structural element of this warehouse, both the police, the rafter, the stanchions, everything successfully. And then we see how we optimize the sections successfully. Okay, so this is the fourth video. This is the fourth video. So if you navigate to our channel, and then you will be able to see the first video, which is this one, and this is the second video. This is the third video on this series. Okay, so if you have not checked these videos, just check them so you can follow alongside. Okay, and then on our channel we have a lot of videos that will help your civil engineering career successfully. Okay, and then don't forget to hit on the subscribe button, and I will advise you to join our channel membership right here. Click on the join to join it. We have a lot of useful video on this membership, so join it so you follow and enjoy our in-depth video successfully. Do not forget to subscribe. So let us get started. All right, now here we go, and we navigate to the 3D just like this. Okay, so you can always use this 3D cube to actually navigate around your model successfully. Okay, so for us to do or to carry out an analysis on this model, you must get to the analysis tab. So in Tekla Structural Designer, you have to make sure that the first analysis you carry out is the this first order linear. Okay, make sure you carry out first order linear. It's very important. So you can go to settings right here. So in the settings, okay, make sure you are on first order. All right, it's very, very important. Okay, so I click on the OK options right here. Come to design right there. Click in these provisions, and then you can see first order. All right, so this is almost or always a default. Okay, it is always a default, but you should be able to confirm it before you carry out. Okay, so for this is for buckling analysis. By the time you check it and then your alpha critical is less than 10, you should go to the second order and the rest of that. Okay, this is explained for our members that actually join our channel successfully, channel membership. I click on the OK option. So we proceed to the analysis. Okay, So I want to validate this model. So I come to model right here and I click on validate. All right, see over here, I already have any warning, okay, on this model. All right, I will proceed to the analysis and then I click on the first order linear. So in the first order linear, I will have to check the loading combinations that I want to actually use. You can select all of the loading combinations, okay, but for the sake of this presentation, we are going to be looking at some few loading combinations like 2 because of time constraint. Because if you select all of the loading combinations, this is going to take longer time to actually load, okay. But during design, we are going to be using the loading envelope, okay, which consists of all the loads, okay. So I click on the OK options, all right. You see, I select on the first order linear, all right, and then I check 2 of these loading combinations, okay. These are the most important one I've actually selected, all right. I click on the OK options right there. So this is going to run the analysis for us. Let's see the result that we are going to get. All right, here we go. So the analysis is done on this structure. You can see over here. So if I select on this result right here, you will notice this is what I have. All right, no member axial forces, no result. You can see. All right, so now come to this loading combination. Select. You can see we have 2 loading combinations that we use. Select the first one. So when you select the first one, you can see, okay, the analysis have actually taken place based on that combinations that we did. So this is as a result of axial forces on the model. So if you select these provisions, you can be able to check moment. You can see. So this is moment in the major axis. You can see right here. All right. So you can also be able to check for the moment in the minor axis as well, right there. Okay, on the model. So from there, you can also be able to look at shear force in the major axis, just like this. Okay. Now, once you have done this successfully, you can also use this one to actually check the level of deflections successfully. If I select on the deflections, I can have my deflected members just like this. So you can actually use this to check the level of deflection. You can see. All right, you see. You can also eliminate this. So this is analysis result we are actually looking at. Okay, so if you select in the ID right here, you can check the reactions. So if you select here, you see reactions. All right, based on the analysis we did, here the reactions generated successfully. So the forces in the member, you can also see it right there. If you select distribution, select deflections, you will also see the deflections right there. Okay, but this is too crowded, you may not necessarily be able to see it. So this is based on these combinations. If you select based on this one, okay, let's just show you none. Select based on this, we have that. Okay, get rid of this one, so this will not be crowded. Okay, so if you want to also check for the elimination, you can select in the space, right click, and then if you select in the space and right click, you will have elimination options here. Click right there, so you can see the model actually eliminating based on the load. You can see, you see. So all right, let's click on the close to close these eliminations. All right, so we proceed. We want to actually go into the analysis now, so we can go into the design. So we have just run an analysis. Want to go into the design so we can design our members successfully. I will come to design right here. All right, so over here you will use, first of all, we're going to use design steel gravity. All right, before we go into statics. All right, so I will just have to change this place to none first. just like this, and then I click on the design steel gravity options. So let's give it some time. All right, the design is successful, you can see right there. So I can now click in these provisions and then select the envelope one, just like this. So you see some of the member has actually passed design and then some failed. Okay, so if I put my cursor on this, you can see this one has passed design at 0.206 utilization ratio, you can see, and then this has also passed design at 0.572 utilization ratio successfully. This one failed. You can see U ratio is 1.06. Okay, so once the U ratio is more than 1, the member failed. All right, so over here you can see the statute right there. So for this member that's failed now, what do we do? At first, we need to go into the analysis and then use this option of design all with this load. Okay, so you click on this design all, and then you give it some time to actually carry out the design successfully. Okay, design is done. You can see even these external members has also failed based on the envelope, you can see. So this is the envelope, which is the combinations, all of the combinations we have body wheel load. Okay, so now what we need to do, once you have your member fed this way, you have to actually check what is the cost of the failure. Okay, what is the cost of the failure, and then you optimize it successfully. So I will show you all of that in this video. So I will start from this member. Make sure you stick to this video till the end so you actually understand how Tekla structure works in terms of design. Okay, I will select on this particular member and I will right click. So I will come to where I have this is check selection. I will click on this static. So I want to know what actually makes it to fail. So you can see I have axial bending combined, I have moment measure right here, and then I have a buckling, lateral torsion, okay, and I have a buckling combined. All right, so once your member failed by these options, okay, that is having red crossed right here, the moment measure, the axial, simply means the member section is not sufficient. That's what they mean. Okay, but this is supposed to be designed automatically. All right, these are supposed to be designed automatically, but we did not check auto design right here. Okay, so if we scroll down right here, you see auto design. So there is no auto design on these members. All right, I keep it like this so that any member that fails actually fails. All right, there's no auto design for it. So now we want to optimize it on our own. Okay, so we select this and then right click, and then come to where we have design selection. So I will use the statics. So this is going to optimize this member and design it, increasing the sections, okay, to 2, 5, 4, 1, 4, 6 by 3, 1, okay, and the strength is 275. All right, so you see all of the failed options has actually passed, and then in the table and the statute you see everything passed. Click on the close option. So if I select on this member now, you see this member as past design. So that is optimization, but that is not all. Okay, we have some other important things we need to do, but we need to optimize all of these failed member first before we should go into that. And I will show you that shortly, that this particular section is not actually the section, because if you put down your cursor on these sections right away, you can see the U ratio is 0.892 right there. So I will select on this member and then I'll optimize it as well. So I come to where I have design member static. So this is going to design and correct by increasing the section. You can see the section here is 406. This is quite large section. All right, but don't worry, we will reduce this. Okay, click on the close option. Select on this, right click, and then come to design member statics right here. So you can see that is done. That has been corrected. Select on this, right click, and then design member statics again. All right, so that has been corrected, closed. All right, take note of the sections that this is selecting for us. Okay, so now we have this for the external rafter. We are having 254 everything has passed design. Click on the close options. Over to this side, select on that, and then right click. So you are still going to use this design member option, just like this. That has passed closed. Select on this, right click, design member static. That has passed closed. Select on this, right click, design member static. This has also passed. So select on this. Okay. This has also passed the design. The last one we have here, design member static. All of the member has almost passed the design. They said this stanchion right here. So this is how you actually optimize your structural element still member successfully. All right, in Tekla Structural Designer. All right, but these member are quite too large. Okay, and then the U ratio is 0.769. Okay, so once you are done with optimizations, you need to carry out the design all options for static analysis. Okay, based on the envelope one. Okay, so you have to do that, so that we now be able to adjust these members, okay, to the right section successfully. All right, so now this member is actually having some warning. You can see over here we have two members warning. So let's check what could cause this warning. Select it, right click, and then come to check member statics. So over here, nothing much, almost every options has passed. Okay, and the section selected for us is 203 203 46. Okay, so now what is the issue is the design note right there, top and then bottom, flange laterally restrained. Okay, major and minor axis struct restraint. Okay, no, okay, there is no, the issue why we have this wording is because we only braced here and then we braced here. This particular column is not braced. Okay, this particular color is not braced. That is why we're having the restraint issues. Okay, so how do we correct the restraint issue? Because we wanted all of these structural element of our design successfully. All right, so now to correct the restraint issues, we need to have a kind of a tie beam, all right, on the column, the top of the column, a tie beam. Okay, so let us do that. Now we navigate to this modeling. Okay, you go to the modeling tab and then you go to the physical model, just like this. Okay, so you can get rid of this the wing the wing panels. To get rid of it, come to the scene content, and then if we come down, you will see we have to look for the roof. This is the roof panel, so you uncheck it from here. Okay, and then we have the wing panel. You uncheck that. We can see they are all gone, just like this. Okay, so we want to proceed to the modeling tab. Select on the beam. We need a tie beam, so I will scroll down right here. I don't want to use auto design. Okay, so I'll select the section of the beam. This one, 203 beam sections right there. Okay, and then I'll get rid of this option. So I'll pick this point, place the beam. You can see, place the beam just like this. You can see. So this will cater for the restraint, okay, to some extent that we can't enable these columns to pass design successfully, I believe. So I placed it right here, just like this. All right. Okay, so now I'll escape since I'm done, just like this. All right, so we want to go back to the analysis tab again, and then this time around we are going to be using this options design or static. Okay, but before we go there, do not forget to visit our channel and check other videos that we have right here on our channels, and then don't forget to subscribe, and I will always advise join our membership. Okay, so you have access to useful videos successfully. Please subscribe to our channel. Okay, so let us make progress. All right, so we come to design provisions right there at the tab, and then we come to the analysis and design options, then design all static. We click on that. So once you click on it, you give it some time to actually carry out the analysis and as well as the design. Okay, now you can see the columns are actually passed. We wouldn't have any warning, just that we are still having this intermediate rafter failing because the sections are too large. So we will carry out optimization on these intermediate rafters as well. So zoom them closely, just like this. Select the first one, right click, and then come to design member, static options, click right there. Here we go. You can see the member are reduced to 305. Before it was 406. All right. So this is the right member for this design. You can see. I click on the close options to have that passed. Select the next one, right click, come to design member, static options. So if you're having issue with your own model, you can reach to me and I'll advise you on what you can do. Okay, I click on the close options that has passed. So select on this design member static. All right, you see section selected 305. All of the design conditions have been met. Okay, close that. So over to these provisions, we select this, right click, and then design statics right there. Okay, everything is okay. All right, now select on this one, right click, design member static. Okay, close this, select on this, right click, and then design member static again. All right, so you see 305 by 165 section selected for this for the rafter of this steel warehouse successfully. So you can now see that we wouldn't have any member actually failing right here. So if we want to check over here, we have 0.4 for the U ratio for that particular stanchion. This is 0.6. Okay, this is 0.661. Okay, so all of these members are actually carrying the loads comfortably. As you can see over here, we have our rafter. This is 0.04. Okay, and then we have our braces. Everything has actually passed our design successfully. Okay, so if you have any questions, you can drop it in the comment sections. If you have an issue with your own model, you just have to reach to me. All right, reach to me. I will advise you on what you can do. Okay, so this member that we were having warning because we actually provided the tie beam. Okay, at the top constraint of the columns, and these members are actually past design now. Everything is good. Okay, so you can see our model. The foundation is yet to be designed. That is why you have this. All right, so if you have any question, just as I said earlier, please drop it in the comment sections. If you have learned new thing in this video, do not forget to also drop it in the comment sections. The next video we'll see how we can actually carry out the drawings and then the calculation sheet of this structural element that make up this steel warehouse successfully. Okay, so this is how you actually carry out your analysis and design using Tekla Structural Designer. Because most people complain that Tekla Structural Designer is not really effective. So it depends on your limit of knowledge. That is why I always advise and invite you to join our masterclass, and then you will learn more about this program, Tekla Structural Designer, how to use it, how to use the releases, and then the constraints to be able to get your design successful. Okay, so do not forget to always visit and make sure you subscribe, visit our channel, subscribe to our channel, and join our channel membership. All right, subscribe, and then there are other videos you can actually look at and learn from it. So this is the first video, second video, and the third one. This one we'll stop here, and then we will see in the next presentation. Stay connected, and then stay safe. Bye for now.